Hey everyone, are you ready to absolutely crush one of the most important chapters for your exams? Today, we are diving deep into acids, bases, and salts. I'm going to break down everything you need to know super fast and get you exam ready in about 5 minutes. So let's do this.
But first, let me ask you something. Ever wondered why a bee sting burns like crazy, but your toothpaste makes your mouth feel all fresh and clean? Well, the secret to both is hidden in the amazing chemistry of acids and bases, and we're about to figure it all out.
So here's our game plan for today. We'll start with the basics, what acids and bases even are. Then we'll check out how they react, learn to measure their strength using the pH scale, and see how this all pops up in our daily lives. After that, we'll look at some really important salts and wrap it all up by tackling a real board exam question together. You ready? Let's jump right in.
All right, first things first, what are acids and bases? Let's nail down the fundamentals so you can spot the difference every single time, no problem. Okay, let's break down the key differences side by side. On one hand, you've got acids, like in lemons. They taste sour and have this cool party trick where they turn blue litmus paper red. On the other hand, you've got bases, like soap. They're usually bitter, feel kind of soapy or slippery, and do the exact opposite with litmus paper. They turn red litmus blue. And hey, if you're having trouble remembering that litmus test, I've got a super simple trick for you. For acids, just remember the letters BRA. That's blue litmus turns red in acid. BRA. See? Easy. So, how do we actually see all this happening? We use something called an indicator. You can think of it like a chemical detective. It's a special substance that changes its color to tell you if you're dealing with an acid or a base. It gives you a visual clue.
Now, litmus is probably the most famous indicator, but in the lab you'll also run into things like methyl orange and phenolphthalein, and here's a really cool one to remember: olfactory indicators, things like clove oil or vanilla. They don't change color, nope, they change their smell when you add an acid or a base. How cool is that?
All right, now that we know how to spot them, let's get into the action. How do they react? Understanding their chemical properties is absolutely essential for your exams, so listen up. Here is the first major reaction you have to know. When you mix an acid with most metals, you almost always get two things, a salt and hydrogen gas. And you remember that classic test for hydrogen gas, right? It makes that little pop sound with a burning splint. This is the reaction that makes it happen.
Let's look at a real example. If you take some zinc metal and drop it into hydrochloric acid, you get zinc chloride, which is a salt, and you'll see bubbles of hydrogen gas fizzing up. This reaction perfectly shows that general rule we just talked about. Acid plus a metal gives you a salt and hydrogen. And here's another super important reaction. Now, the key thing to remember here is that most metal oxides are actually basic in nature. So when a metal oxide reacts with an acid, it's basically just an acid-base neutralization reaction. And what do you always get for neutralization? That's right, a salt and water. Simple as that. Okay, but it's not always enough to just know if something is an acid or a base. Sometimes we need to know how strong it is. And that brings us to our next big topic, the pH scale.
So what is the pH scale actually measuring? Well, it's all about the concentration of hydrogen ions, those little H+ things. The more hydrogen ions you have floating around in a solution, the more acidic it is. And here's the tricky part: the lower its pH number will be. Just picture a number line that goes from 0 all the way to 14. Anything with a pH less than 7 is an acid, with 0 being the strongest, most acidic you can get. Anything above 7 is a base, or alkaline, with 14 being the strongest. And if you use a universal indicator, you'll see these awesome color changes, usually turning bright red in strong acids and a deep blue or violet in strong bases. And what's sitting right there in the middle? A pH of exactly 7. That's perfectly neutral, not acidic, not basic. And the best example of this, of course, is pure water.
Okay, this is all great for the chemistry lab, but why should you care? Why does any of this matter in the real world? Well, let's take a look at just how much pH affects our everyday lives. This is where it all clicks into place. You know tooth decay? It starts when bacteria create acid in your mouth, dropping the pH below 5.5. That's why your toothpaste is basic, to neutralize that acid. Or that painful bee sting, it's injecting acidic venom. So applying a mild base like baking soda can help relieve the pain. And indigestion? That burning feeling is from too much stomach acid, which is why antacids work. They're just mild bases that neutralize it. Next up, let's talk about salts. And no, I don't just mean the stuff you put on your food. We're talking about fundamental chemicals for industry, and believe it or not, a lot of them come from the one salt we all know, sodium chloride.
It's actually pretty amazing what we can make from just plain old table salt. Through an industrial method called the chloroalkali process, we get sodium hydroxide, a really powerful base used for making soap and paper. We also get baking soda, that mild base we use in cakes and to fix indigestion. And of course, there's washing soda, which is an amazing cleaning agent and is great for softening hard water.
Okay, time to put all this knowledge to the test. For our final section, we're going to walk through a typical board exam question step by step so you can see exactly how to apply these concepts when it really counts.
Whew, that was a tough one, but you did great. So before we go, let's do a final, super quick summary of the most important things to remember. Acids are sour and turn blue litmus red. Bases are bitter and turn red litmus blue. The pH scale, from 0 to 14, measures their strength. Acids reacting with metals give us hydrogen gas. And salts? They're formed when an acid and a base neutralize each other. Got it? Awesome.
All right, here we go. A classic exam-style question. I know, it looks a little scary with all the numbers, but let's just break it down. We need to figure out the volume of carbon dioxide we get when 50 grams of calcium carbonate reacts with 7.3 grams of hydrochloric acid. Don't worry, we're going to solve this together.
Okay, let's walk through it. Step 1 is always the balanced equation. This tells us the exact ratio of our ingredients. Step 2, and this is the most important part, is finding the limiting reagent. Think of this as the ingredient you're going to run out of first. Our calculation shows that for 50 grams of calcium carbonate, we would need 36.5 grams of HCl to react with all of it. But look at the question. We only have 7.3 grams. That means the HCl is our limiting reagent. It's going to stop the reaction early. So for step 3, we use that limiting reagent to find our answer. The full recipe says 73 grams of HCl would make 22.4 liters of CO2. Since we only have 7.3 grams, which is exactly 1/10 of that, we're only going to make 1/10 of the product. And that gives us our final answer, 2.24 liters. The secret is always to find that limiting reagent first.
And to wrap this all up, here are 10 questions to really test your knowledge. Go ahead and pause the explainer here, give them a shot, and see how you do. Keep practicing these concepts, and you are going to be in fantastic shape for your exams. You did an excellent job today, and thanks for watching.